everyone. Good evening to all. Hope everyone is good. Welcome to our day 3 session of certification program on machine learning and GenAI. Hope you have enjoyed the last two sessions, and I am so thankful that really getting very good feedback from you people. So and also I'm taking that summarizations of all the feedbacks so that how I'll it will be better for me. How can I improve in delivering my lectures? So most of the people are saying that yesterday while doing the Google Colab, they are completely unaware of AML and Google Colab, so they don't know how to uh, do that Google Colab. It's like a uh, bit fast, so they are not able to. So few people are commenting like it's very difficult to load the data set. They couldn't able to understand the loading the data set. So after the loading the data set, the complete code was disturbed. So they can't able to load the data set. So after that, they are confused and they can't able to understand the coding. So most of the people commented like that. So, and few people are commenting like they need to hear some data, I mean, some programming in medical field because most of the people are from medical field, and few people are commenting like that. So, what I thought for the next, this one is linear regression. Yesterday we have seen already. So, after this, we are going to see logistic regression. So for that, I'll take some heart healthcare data, so heart prediction data, and we'll see how on that we will work on logistic regression. And a few data we'll consider in health side, and we'll see that. And one more thing is, few people are asking like weekends the session should be there, but already the timeline is decided and the day-to-day schedule is decided, and everyone are registered according to that, and mainly this program concentrate for the working professionals also. So this time is everyone are officials or higher officials, and everyone felt that this time is good for working and good for learning. So that's why we thought on weekdays, because weekends you'll get time to practice. So weekends no sessions will be there. Up to Friday we'll have. Of course on Friday again I'll discuss all the whatever quiz you are attempting on all these days. That complete question and answer sessions I'll discuss on Friday. So from day one, whatever the questions you have answered, I'll explain each and every question on Friday, and we'll have all the sessions on Friday, question and answer sessions, and all the doubts I'll clarify on Friday. So there won't be any special sessions on Saturday and Sunday. So Saturday Sunday will be your practice time. And few people are commenting like workbook you want me to share the workbook. So today we have planned once I'll start the practical session, we will share that collab workbook to you. Whatever experiment I am going to teach here, that I'll share to you. So automatically you can open that Google Colab, but don't copy paste that. You just keep it aside for your reference material, and by seeing that you can do that same code. The same code I am going to explain here. So if you are can't able to visit visible, this screen is not visible, then you can do that also. And few more comments are so everybody are saying that it's you are enjoying the classes, and I'm very thankful to you. So I am happy that you are understanding my lectures, and few people are asking like concentrate on GenAI more. See, GenAI is a bit advanced compared to machine learning and deep learning. So if you don't know the basic concepts of machine learning, you cannot you don't know even what is a GenAI. So to get GED, you have to learn A. So once you completely you complete that sequence of ABC, then only you can go for a JET. Directly you can't learn JET. That's the same thing. Why I am concentrating most basics of ML first. Then we'll learn in the next week DL. Then we'll go for GenAI. So this is the comment review of yesterday's feedback. So anyway, yesterday I thought today I'll directly start from logistic regression, but most of the people said that they cannot able to understand the linear regression yesterday, the collab and the practice sessions. So just I'll in 2 seconds I'll complete again this one. So we'll memorize again linear regression. Yesterday I explained the types of the machine learning algorithms. So in machine learning algorithms, I have explained three main types we have. One is supervised, one is unsupervised, and one is reinforcement learning. So supervised learning, we have again sub two parts, classification and regression. So in regression part, first one is a basic algorithm is linear regression. So when we will go for regression problems, I already explained you whenever we have a continuous outputs, and when we want to do some numerical analysis, like for particular age, what is the salary? So salary will be a continuous output. There will be dependency between the outputs. So whenever you have that type of outputs, then we'll go for regression problems. So we'll see the linear regression. So linear regression works on basically on a linear relationship. Suppose I have two variables, only two variables I have. So let's say this is age and this is salary. Whichever we already did an hands-on. So two variables here I have. So in these two variables, this salary is completely dependent on this age. So I can call this is an independent variable. Only two variables, and one is independent and one is dependent. And it's a continuous variable. Then we can call it as, and we can make that as, so this part, let's say this is some y. So y I can calculate using my x. So some function of my x. By taking some function, some calculations on this x, I can do with y like this. If suppose age is some 0, some 5, some 10, some 20, some 30, like this I have. And salaries I have some 3,000, 4,000, 5,000, 7,000, something like that. So whenever I know x, I know the value of y. So here 1 point, here 1 point, here 1 point. So I can plot the points. So whenever I know x, I can easily calculate y. This I can plot here. So from this I can fit a line. I can fit a line like my graph will be like this, or like this, or something like this, or someone it's going from this. So I can plot a line. So just assume instead of having some curvy shape, if just assume this is a linear relationship, then I can write this curve is equal to y equal to mx plus c, as we have studied in our basic mathematics. So here y is nothing but the output, means salary in our case. This x is nothing but age. So this m is how that curve is like this. The line is the slope of this line, and c is the intercept from the x-axis. So by using this line, I can, when I know the age of 45, now I want to find out the age of 45. I want to predict the salary. So easily I can predict the line. So this is my salary. So I can easily predict using that line. So this is basically what happens in linear regression. But what's the problem? Here I can draw any line like this. But how can a mission, by seeing this as a human with my natural intelligence, I can say which one is the best line. How I can say, so this line is going through so many points, and of course it is giving the correct prediction. So I can easily say this is the best line. But how a machine can know that? How can we say in these four lines which is the best line? So that we call it as in linear regression, we call that as a best fit line. So that a model should predict. A model linear regression algorithm should calculate that particular line, best fit line. Then only the algorithm will be better. The accuracy will be more. So to select which line is a best fit, we go for least square method. Least square method in linear regression. Least square method. So least square method is nothing but, so suppose this is my line. Just to say this is my line. These are my data points. This is one data point. This is my data points. Now assume the machine has predicted this is our best fit line. This is my best fit line. So at the age of some 10, 20, 30, and 40. So at 40 years, actually, the actual point is here. This is actual point. So y should be here. Actual y. Y actual. So salary should be like this in actual. But machine has predicted this is the logic. This is the model. This is the model. Second. This machine has predicted line. But in actual case, suppose I want at this age of at this point of age some x1. Actual y is this one. This is actual y. This one is y actual. But machine has predicted this is the best line. This is the logic prepared. So now my y is for this x. This is my y, predicted y. Because machine has decided this is the best line. Then what is this one? There is an error. There is a gap. Actually, this is the y, but this is the predicted. So this is the error. So y actual minus y predicted. So this thing we call it as cost or loss. Cost or loss. So least square method will try to minimize this thing. Least square method will try to minimize this thing. So it will move this line to up and down. It will move this line. So wherever you get this error minimized in each and every point. So each and every point, here one point, here one point, here one point. So it will check for all the possibilities of the lines, and wherever the distance between the actual point and the line predicted point, wherever the distance is minimum, that line will be considered as best fit line, and that will be finalized as a regression line, and that we will take it as our model. So that what happens in least square method. So it will minimize the errors, the distance between y actual and y predicted line. See, this is the y predicted for this line, but if you take this is the line, so this is the y predicted line here. So this difference is very less compared to this difference. Like that, it will be predicted in linear regression. So this is what happens in linear regression, basically. So this is the cost function or loss function. So linear regression always try to minimize the cost or loss. between the actuals and prediction. And to how we will reduce more this cost and loss functions are we by using a gradient descent. That anyway we will see in the next class optimization techniques. So to minimize this more completely, that we use some techniques or some optimizing techniques. So that is called gradient descent techniques that we'll see in the next class. So this is the basic understanding of what happens in linear regression. So in linear regression, as I said, if we consider only one variable as dependent, one variable as independent, one variable independent, one variable as dependent, then we call this type of regression as single regression, linear regression, simple linear regression. If there are so many, different features are there, independent features are more than one, and one dependent variable, then we call it as multi-regression. If only one independent feature and one dependent variable is there, then we call it as simple linear regression. If we have more than one feature, I mean more than one independent variables, then we call it as multi-regression. And suppose here I have only variable as salary. Salary. Only one dependent variable is there. Only one I have to predict as a output. In that cases, the regression is called a single variant regression. Single variant. If here instead of having a one single variable, we have different variables and we want to predict all these more than one, then we call it as a multivariant regression. So there are four types. Anyway, that we will discuss while doing the optimization techniques, because for the optimization technique, the same program we'll use, so it won't take much time. Anyway, you will get all these ideas. So we'll use that for optimization techniques. There we'll discuss, we will add one more variable also here. We will see that how it will work for a single variant and multivariant, and also simple linear regression and multiple regression. Now I'll share that link of the linear regression again now. So I'll explain again that program, then I'll move to logistic regression. Now I'll share the, 1 second, I will share the data set and also the link of the program. I'll share you the link of the program. So before sharing, one more thing I want to tell. Linear regression mainly used very simple technique and mainly used for a basic regression problems. Some weather prediction or some uh, stock exchange, forecasting, sales, mainly for sales. So in all these cases, we use a linear regression problems. So linear regression thing we are going to share now. Please check. And then once you complete this linear regression, you'll understand just 2 minutes, you'll check that program. I'll explain again. Then I will go to logistic regression. I hope everyone got that link, linear regression. So first step for any machine learning algorithm, as I said, first step is importing the libraries. And second step is loading the data. So first step is importing the libraries. Second step is loading the data. And third step is splitting the data into training and testing parts. So yesterday I have told you why we have to split the data. And the next step is building the model. And the next step is and the next step is and evaluating the model. So here our first step is importing the libraries. So anyway, NumPy library is used to import all the arrays when you are going to work on arrays and when you are going to work on any numerical things, we are going to import the NumPy. So we cannot use the NumPy completely everywhere. So just I'm giving a shortcut of NP. Similarly, pandas, we always work on here in machine learning. Most of the times we are going to work on data frames. So data will be converted into data frames, and on that particular data frame, we are going to work. So I'm importing the pandas, and that pandas I'll keep it as a simple manner as PD. And matplotlib is a global library, matplotlib. So it is used for visualization. Now, any graphical purpose, any results you want to represent in a graphical manner or pictorial view. So there, for that purpose, we are using this matplotlib. So in that, we are using Python as pyplot. So that I'm giving shortcut as PLD. So these are the libraries I need for this particular project. There are so many libraries, so you can import that also. Here, these three are enough for this program. This is basic program. And next step is loading the data. So for loading the data, I already shared you the data set. So first, there are, if you are using a Jupyter notebook or Spider notebook, directly you can give a variable equal to, this is the function, pd.read. PD is nothing but pandas. So using pandas, the function is read. So it will import the load the data. So read underscore CSV. Here you have to give the location of your file, where you are keeping your file in your desktop or laptop. That complete location you have to give it here. If you are using a Jupyter or a Spider notebooks. So if you are using Google, there also you can give directly, location, but in simple manner, I can import that in my, I'll load that data set in my drive. So for that, you have to use this upload link. Here upload session upload will be there. This is the session upload. Session upload in this will be open. So here you have to give your file name. So my file name is salaries. So I'll give that salaries I'll give. So salary data I'm selecting here. Clicking open. So that data set will be coming here. You can see the data set is imported into your drive link. So now if you run this thing, the data will be uploaded here. So here data set is nothing but my variable. In that where I kept my data set. So data set dot tail means it will show the last 5 rows of data. So if you are giving head here, the first rows of data it will be shown to you. Dataset dot head and dataset dot tail. And then these are the first two steps. Next step is data pre-processing. So in data pre-processing, what we are doing, we have two variables here. So for the mission, we have to tell which one is the feature and which one is the label. I mean, which one is the input and which one is the output. So I'm just separating these two. In X, I'm keeping all the inputs. In Y, I'm keeping all the outputs. So for that, the function I am using is ilog. Dataset is my variable dot ilog. So this colon first in braces, the colon first colon says that if you are using only colon in Python, that states that I want all the rows of my data set. I want all the rows of my data set. So just giving colon means I want all the rows. And that in next I'm separating the rows and columns by a comma. And next I'm giving here colon -1 means that last column I don't want. So I'm just eliminating the index of the one column. So 0 and 1. So I'm eliminating that index. So here, if I give this only in X, I'll get only independent variables. I mean, inputs only I'll get. And the next Y, I am locating colon, comma, 1. So I want all the rows. And of course, I want colon only. The first one I don't want. Only one colon only I want. So I'm giving 1. And dot values means all the values in the data set I want, not only the data, index numbers or row numbers. Just in that particular row, I want all the values. So I have added dot values. So this is the pre-processing we did here. There are many techniques of pre-processing, but here we are doing only this pre-processing technique. Next thing is splitting the data. Next step is splitting the data. So here the splitting the data. sklearn library is the primary library in machine learning to download all the test split, test try and split functions, and of course any which type of algorithm you are using, whether it is a linear regression, logistic regression, any algorithm you are using that. So to download that is the basic modules sklearn library. So from that I'm importing test underscore train underscore split. So now in that, I have to tell the mission. Some data I have kept for training, some data I have to kept for testing. So what type of data, whatever data I'm keeping for training, that I am loading in xtrain. Whatever data and particular inputs I am keeping it aside, that I am loading in ytrain. Whatever data I am keeping for training, but particularly that is output, then I am keeping that in Excel test. So input and output we have to separate, and also for training and testing. That we are doing here. And of course, here we have to give the test size. So how much data you want to keep it aside? Whether that is a 30% data, 40% data, 60% data, whatever may be the data. So here 1/3 of data I'm keeping aside. So that is my test data. Random state is nothing but just to avoid the randomness of the results. So if we are giving random state equal to 0 means every time the rows order will change while training. In training, suppose it is considering 70 rows. So in 70 rows, the order will change each and every time, and the results will be vary every time. So maybe the randomness will be increased. So here I am giving the random state is 25 means 25 times the same rows will be generated for training, and same results will be updated for 25 times. So the analysis will be easy for 25 times. So 26th time the rows order will change and the results will appear. Different results will appear. So so that is what test to try and split. The next thing is building the model. So in building the model, we are going to use linear regression. So I just imported linear regression here. And now whatever data I have, now fitting is like building the logic. So in between the inputs and outputs, I have to build the relation, right? So that relation in syntax model, we call it as fit. So we'll fit the line. We'll fit the line between in which we have to fit training. X train and Y train. Between the inputs, we are fitting the line. So now, after fitting the line, now I'll give the unseen data to the computer. So I kept aside the unseen data. I'll give it to the computer. Then this will, no, I'll predict the results. So here I have predicted X test and Y test. And this is the visualization using a matplotlib. But here I'm using a scatter plot. To visualize the results, I have used a scatter plot. So this is my scatter plot line. This I'm just giving the labeling. So title, plot X label and Y label. And this is my final plot, what I have drawn. So these are my data points and this is my best fit line. Maybe the computer first analyzed this is the line, but after calculating the least square methods, it is the final best fit line for this model. This is what the linear regression. Hope you understand this one. So now my accuracy here R2 score means in regression that is the score, rank like accuracy. So that is I got 0.94. So means 94% correctly my model can able to predict 94% correctly my mission, my whatever model I have built, it can able to predict correctly up to 94%. So that is what it means. So this is what linear regression. So hope you understand. If any doubts are there, please post it in the comment box. Now, in 2 seconds, I'll move to the next logistic regression. So I have shared you the link, the lab link. So if you are unable to follow here, you just go through that code. Anyway, you listen now, you just go through that code. Once you understand, that is the basic level of coding. Here, one more thing I am telling, inside so much code we can include, but this is the basic level of coding. Only 5 steps, major steps are there. So I'm not including any sub steps. This is the major steps for any algorithm we have to follow. So that steps only I have considered, and I'm dealing that steps. So next we'll go for the logistic regression. Here itself I'll tell. So this is what we have seen the linear regression. Now we'll see the logistic regression. So suppose I have a data like, a person weight on the x-axis, and a person whether he will get a heart attack or not. So how it will be? Suppose the weight is very less at the starting level. Some here this is, so on x-axis some 10, 20, some 10, 20, 30, some up to some 60. Just make it as a threshold. So up to 60, the person will not get a no heart attack, very less chance of heart attack. But if the person is weighing some above 90, so 90, 100, more than 90, so the person will have a maximum chance of getting heart attack, yes. So if you want to plot this, how can we plot? So all the points of here will get like this. So all the points will be here, and for above 90, all the points will get somewhat here. All the points will get somewhat here. So what you understand with this? If you plot this, so almost I'll get here a straight line, here a straight line, and here a straight line. So data points will be here only for a particular group, and data points will be here only for a particular group. Now, according to our linear regression, I have to plot a line, some lines. So how a linear regression will solve this problem? How do you think any linear regression, any best fit line will occur in this type of case? So anyway, suppose the person has some 35 years, some 75 years. So 75 years means somewhat here. The fit line will be, suppose let's say this is the fit line. So 75 weight means 75 kgs of weight means the person should be here. So whether it is yes or no, we don't know. Linear regression will fail in particular cases. So in that type of cases, what we'll do is, suppose this is our two data points. In that type of cases, instead of using a straight line, we'll use a sigmoid curve. Instead of using a straight line as a best fit line, we'll use, instead of a straight line, we'll use a sigmoid curve. So sigmoid curve, S curve will say. So this sigmoid curve will decide a threshold value. Will decide a threshold value of 0.5. Let's say this is 0, this is 1. So we'll decide a threshold value. So whatever the element below this value will get no. Whatever the value above this will get AS. So this type of algorithm we call it as logistic regression. Why we are calling this logistic regression? Because if you observe, this is the classification problem. We are deciding yes or no. We are classifying that problem. It's not a continuous value like that. It is a classification problem. But why we are calling regression again? Because the values will be somewhat continuous. So both the things are there. So this is the main beauty of logistic regression. So this is a actually classification problem, but the operation will be like a continuous work. So instead of using a simple straight line, here we'll use a sigmoid curve. That is the difference. And here we'll have a threshold value. Now we'll see the hands-on of logistic regression. So I'll share that link also now. Please go through that. Logistic regression link I'll share you now. Logistic regression, and also data set will be here. I'm using heart data because few people are asking for medical. So I'm going to share that heart data set and also logistic regression link. So we will share you the heart data set and also logistic regression link. So this is the logistic regression link for this. And here, so first step is nothing but importing the libraries. So I have imported the library here. Imported the library here. So first here I have imported pandas as PD. Pandas as PD. So next step is loading the data. So here I have again here I have considered the variable as df. I've considered the variable as df. PDF, I am going to load my data. I have selected the load. I've selected the upload session, and here I'm selecting the hard file. Open. So remember one more thing, this upload is for session upload. So after this session, it will go. Again, when you start this session, new session, you have to upload it again. So hard data is there. If you want to see this data, you just click on that. So on the right side, the data set will be opened. If you click on that data set, the data set will be opened here. See, this is the data set we have. And here a total of 303 entities are there in this data set. And of course, here if you see the data set, we have so many of the features: age, sex, chest pain, rest BP, cholesterol, FBS, ECG, and here so many features are there. And one predicted variable is AHD, whether the person will get a heart attack or not. So this is my dependent variable, and these are all my independent variables. So many features, and of course only this is the dependent variable, one label output. So now I have to predict this AHD depending on all these features. So here if you observe this data set, few elements are like, see here, this is a characteristic values in thal, and of course in chest pain again we have a characteristic values, and of course the remaining things are numerical values. And if you observe again, some columns or some feature columns are somewhat zeros and ones, and some feature columns are 233, somewhat in the range of some 500 or 300. 300 to 500, 200 to some 500, and some columns are like 50 to 60. So completely different. The data set is not cleaned here, and you can observe somewhere it may be some null values that we don't know. Somewhere it is mistaken, somewhere it is, some things will be there, some duplicates will be there. So here zero is repeated again and again. So machine will not able to understand all these things. So maybe any empty cells are there that we cannot know. In 303, we have to check manually if you are doing manually. Means so everything before starting the machine learning algorithm, we have to tell that machine that these are the null values, these are the duplicate values, everything you have to do. That we call it as pre-processing, and in this session we'll see that. Now we'll move to this program. So now I have loaded the data set. So I'll run it. First I have to import the data. I have to import. First I'll import the data, pandas as PD. Then I'll load this data set. This is my complete data set. So only first five we want to see, just df.head. First five rows it will be appeared. So here if you see, this is something like unnamed zero, that we don't know what is that feature. There is no name, nothing. Just they have given unnamed. So what do you think? That feature is not useful for us. It's an extra feature. Whatever I say, outlier or no extra feature, nothing, no useless feature. So in data preprocessing, we can remove that feature. Maybe age will be some effect on our variable. Maybe sex will be some effect on our output. So everything other variables we can know some effect, but unnamed is nothing, no useless. So we can remove that. So we'll go to the next step. So next step is data.info. This is the one type of pre-processing techniques just to analyze the data. So here non-null means there is no gap. There is no empty cell. So no empty cell is there. In that 303, in the unnamed column, 303 are non-null. So anything is something is there and all the integer values are there. So just analyzing the data set, that is df.info. So like that, each and every column will be studied. And next thing is data.describe you can give. So data.describe. So data.info and data.describe, it will give you the analysis part of the data. So data.describe also, it will describe about the data set. What is there in the data set? What are the null values are available? What are the how many string values are there? How many integer values are there? All is that about the data. It will be explained in using data df.describe. So next thing is, as I said, this unnamed column I don't want. So what I am using df.drop. So I just want to drop that particular column because that is useless for me. So what I am doing, I am taking that again my variable data set variable df. In that df, I'm just using df.drop columns of unnamed. So in the output, you can see the unnamed column is dropped here. Similarly, here I have already told you these two are characteristic values, but machines will not know what is a character value and what is a numerical value. So we have to tell that we have to convert all the characteristics values into integer values. Then only the machines will understand. So here two things are there. Just pane is there and thal column is there as a character value. So now I want to convert that character, chest pane column into a numerical value. So first I am giving the category of the column, particular column. So that category is a string type. And then I'm converting that into a numerical value. So that converting, we call it as encoding. Encoding in our machine learning. So we'll use cat coding for that. Just give dot cat dot codes. That will be converted into numerical values. So here if you see, if I run this, so all the chest pane, it will be assigned a number. So non-typical, it will be assigned if 0. So all the non-typical will be assigned as 0, and non-angular will be assigned as 1, and asymptomatic will be assigned some number. So using the alphabetical order, it will be assigned some number. So everything will be converted into a numerical values. Similarly, the remaining two, TAL also have character values and AHD also have character values. Yes and no. AHD also have character values, whether a person will get heart attack or not. So AHD. So everything now I have converted into numerical values. Now my data set is in a consistent manner. So if you see here you are getting a NaN in CA column. In the data set you are getting a NaN. NaN means there is a null value. So now we'll check here whether any null values are there in your rows or columns. So the function is dot is null. If you give dot is null, it will give you how many null numbers are there. If this sum means if you are not giving this sum, then it will show it as an array. How many null values are there, that it will be showed like an array values. So if you give that sum, it will summarize everything. It will aggregate everything and it will show you. See, in CA column you have 4 null values. The remaining everything are no null values, zeros. In CA only you have only 4. That we can remove. So next I have null values, so I am dropping that null values. Drop NA. df equal to df drop NA. So all the null values will be dropped here. See, in the previous slide you can see plan is there in 302 row. Here you don't see that row. You just drop that complete row. Wherever null is there, you just drop it because that is not that much useful maybe. So already I told you this, whether that null values will be removed, ignored, or you have to fill manually or compute. In the first day itself, we have studied this. If that is a very important feature that is affecting our variable means you cannot able to remove that. You have to use some statistical methods like mean, mode, median, anything you can use, and you have to fill the average value there. That we'll see in the coming classes. So here anyway I have dropped the column of null values. And next thing, I have to tell that machines that which are the features and which are the variables. I mean, which are the features and which are the outputs. So what are the inputs and what are the outputs? I have to assign that machine. So that's what I'm doing here. In X, I'm just assigning that, other than AHD, the remaining all the columns should be in X, my inputs. So what I am doing, just AHD column only I'm dropping. The remaining complete thing should be in my X. So df dot drop, only AHD column I am dropping. So here's if you run this, so other than AHD, all that columns will be appeared in X. And now in Y, the AHD column only I want. AHD column only I want. So in Y only I have only AHD column. So this is my X and this is my Y. And once I have assigned X and Y to the machine, now my next step is I have completed the importing, I have loaded the data set and I have, did the data pre-processing and I assigned X and Y. Then next step is splitting the data. I have to split my data set 303 rows into some training data and some testing data. So I have imported the train and test split and then here I am giving the test size as 0.3. Means that you already understood that 0.3 means 30% I kept as a test data and 70% I am going to use for training. And here random state I am using as 23. That number actually depends on your application. You can give 0 also. And sometimes giving 0 will give you a better results because every time you can analyze that results, but sometimes giving the random number more will give you better results. So that depends on your application and it's like uh, while practicing you are able to decide what number I can give as a random state. And next thing, after splitting, I just want to see what are the rows I have in my X train. So if you see the rows, there won't be any correct order of rows. It's not like 1, 2, 3, 4 up to 70. It will take it will take any rows, any type of rows it will take. That depends on. I forgot to run all these things, so I'll first run. This is my X train. So see, random state I have given 23, so 20 up to 23 times. So how many times if I run, I get the same row sort. In 24th time, it will be changed. So exit test, I have kept unseen data. So this is the data. I have kept aside. So this system, the computer don't know this data. Now, as I said here, the data set is completely different. Some values are from 0, 1, and some values are like 40 to 50, and some values are in 200 range, and some values are like 500 range. So I have to make all the features in a standard the values, like a consistency I have to maintain. So for that, I am importing a standard scalar. Normally, what we do when you do a graph or something, so you will use a scale. Scaling part you will use. So each things, each x and y values, you'll scale it up or scale it down. Then you'll plot the graph. The same thing happens in here also. I'm just downloading the standard scaler. So here, standard scaler, I'm applying for my x train and y train, x train and x test. So downloading the standard scaler from again scalar library. So for my x train, I have scaled and I'm fitting the function. Scaling function I'm fitting. My x trained now, you can see the range. Everything will be in a particular range. The consistency will be applied. See, if you see the arrays, if you see the data set numbers there, and you can see here, everything will be in the in a particular range. Everything will be scaled. So this is my x test scaled. Now training and testing is over. I have split it perfectly, and then now I will use the logistic regression. My building, my aim is to use the logistic regression for this particular algorithm. So I have imported the logistic regression from again sklearn library, and the log underscore rich here I have created. This is the default actually variable. In this, I am going to fit my line, my training and testing. So that training I am going to apply for exit train scaled and exit test scaled, everything scaled. For that only I am going to fit my logistic regression. Now once I have trained, so I'll train this. So I have predicted this one. Once the training is over, once the model is built, then I am going for evaluation. So this is my score. 87% I got the accuracy. And for the testing, in training period, I got the accuracy as 87%. In the testing period, I got the accuracy of 81%. These remaining things from lasso and all these things we'll see in the optimization techniques. This is uh, how to improve these two values. Like in regularization methods, we'll use lasso and ridge regression. So that things we'll see in next class, next session. So I'm not going to discuss these two. Up to this, we'll close now. So this is the accuracy I'm getting in testing and training period. So this is what about logistic regression. So particularly logistic regression, we apply wherever we cannot able to split the data using a normal straight line. We cannot able to relate the input and output using a linear regression. In that particular cases, we go for a logistic regression. So we'll have a break now. I'll share you the quiz questions of today, and you try to deal that questions, because that questions will consist of all types of whatever theory part we have discussed yesterday, means supervised learning, unsupervised learning, and this linear logistic. So all these things, based on all these things, you try to do that theory part this session. Then we'll come back and we'll see how KNN works and naive Bayes works, and of course clustering, k-means algorithm works. So now I'll share you the link of quiz session. Please go through it. We'll finish the quiz session, and remember, quiz session and feedback only will give you the attendance of the this session for a particular day. That attendance will be provided once you once you write the quiz, whether you pass or fail, whatever may be, that marks, it's not important, but you have to attempt that quiz. Then only you will understand how much you can able to answer that questions of measurement. In a few minutes, we are going to share you that quiz link. Please do it. Come back. So I hope you enjoyed the quiz session. Everybody able to attend the quiz? Oh. So next we'll move on to another classification algorithm. We have seen logistic linear regression and logistic regression. Next we'll move on to another classification algorithm, basic classification algorithm. So that is KNN. So yesterday I have explained you how a KNN algorithm works. Just like yesterday I told you like a simple example like you are moving into a new city and how you gather your interest. So you just meet the people and whoever are similar to your likings. So you'll group with that member. So like that you'll group your similar people and you decide where you have to go. So your most of the similarities in like uh, education or your most similar people, your taste is like in dance. So after meeting so many people, calculating their wavelength and your wavelength, like distance, we call it as in KNN, calculating the distances, then we'll decide that a person will decide that where he has to go, whether he has to go to education lab or whether he has to go for a dance club or anything. So like that, the same way KNN works. So it will group the things in depending on the similarities. It will cluster, it will group the data points depending on the similarities. So KNN is basically this K means actually the full term is K nearest neighbors. So if new data point comes, so the algorithm works on the nearest points of that particular new input point. So in on the nearest points, it will choose how many nearest points are there from that group and how many nearest points are from this group to that new input point. So wherever the majority nearest points are there, so that new point will go into that particular group. That is what it means in nearest neighbors. K means how many numbers we are going to choose as our nearest numbers. So whether we are choosing for a new input, new data point, whether we are going to choose 5 is enough, our nearest points, or if we want 10, or if we want some 20, anything that we have to choose. Uh, so that is what K means. So K is an integer number. How many nearest points you want to choose before starting your algorithm. So that is K. So default it is 5 or 10. And it is a instant based learning. So that particular instant, what action it is going to take. And of course, one more thing about KNN algorithm is it's we normally call it as a lazy algorithm because it don't want to store anything in its storage. So it's just memorize at that point and take the action for that at particular time. So it will not store any history of the data. So it's just like lazy algorithm. But choosing K is there is no particular rules and regulations to choose that value of K. Just by training itself, we can decide what is the best K. This is the how KNN works. So this is now my new point. Let's say this is my new point. So I am choosing here my K is 5. So in that 5, by calculating the Euclidean distance. So we have studied in our 7th or 8th maths, basic maths, Euclidean distance that you can see this one. Square root of some x2 minus x1 whole square plus y2 minus y1 whole square. The distance, how we calculate the distance between 2 points. So we'll calculate the distance between this new point and each point. So here we have chosen k equal to 5. So we have chosen these are the nearest points. So for this nearest points, for each and every point, we'll calculate the distance. Then after calculating the distance, we will decide how many majority of points are there close to this new point. So here the majority is closed. Here chosen in the green color. So this new point will come into this category A. So this is how KNN works. So the main advantage of KNN algorithm is it's very easy algorithm and just easy to implement. No, nothing very difficult, complex syntaxes will not be there in KNN. This is the very basic algorithm of classification. Of course, very efficient algorithm also KNN. And here we don't need to give much training period. So automatically, depending on the distances, it will adjust. It will that distance depending on the Euclidean distances, it will decide in which group it has to grow. It has to grow. So versatility is more for this. And the main disadvantage of this is each and everywhere the memory should be the where that point is there's a distances while calculating the nearby distances it has to remember all the distances. Suppose if your k is very bigger value, some k is like some 100 values you are taking as the nearest neighbors, so for each and every 100 values it has to remember the distance at that particular instance. Then that is the main disadvantage of this. So memory will be wasted there. And very sensitive to irrelevant features. So very sensitive. If suddenly some incident occurs, then it is very very sensitive to that features. So that is the main disadvantage of this KNN algorithm. Now we will see in Conab how it will work. So I have shared you. Uh, we are going to share the link for KNN algorithm. KNN algorithm. We will share that link in a few minutes. KNN algorithm. I have shared already. So here also the same steps will be repeated up to a few things. Here instead of downloading the some data set from Kaggle or somewhere, some Google, I have downloaded a free dataset which is available in sklearn library. So already sklearn library, I told you all our algorithms, our tests, train, split functions, everything. Most of the things whatever we use in machine learning that will be available in sklearn library. So the same thing, some few data sets also available. Already pre-processed data sets are available. One data set is iris data set. So directly I'm loading the iris dataset from this library. sklearn dataset, sklearn dot datasets. I'm directly downloading the iris library, iris dataset here. And directly here I'm using. Next step is it's already pre-processed itself. So I'm not using any data pre-processing techniques. Directly I'm going for a try new test script. So first I'm importing all these things. Whatever I want, first I'm importing all these things. So first I have imported the data set. Then I have imported the train test split and then imported whatever algorithm I want. So sklearn, I want KNN algorithm. So in particular KNN, it's a classifier I want. So K neighbors classifier I have imported. And here, as it is a classification algorithm, I want to see how much accuracy is there. If it is a regression algorithm, mostly we'll go for R2 score. So if it is a classification algorithm, I want to see the accuracy. So I have downloaded the accuracy and score. Now the second step is after importing the libraries. Now my target is to load the iris dataset. So this is the iris dataset I have downloaded as an array. Not using any data frame here. I'm just downloaded as an array. So load. Here I'm not using this icon. I'm not downloading that session upload. Just directly re-downloaded. So I downloaded this iris dataset. So this is my iris dataset, and you can see this is just I'll run it all the cells. You can directly run here. Run all means all the cells. You can run it here. And remember this one, everywhere you just give the title for each and every project. Otherwise, it will be saved as untitled one, untitled two. So whenever you start a new project, just remember to give a name. So here I have given KNN symbol. So like that, you have to give a name. Otherwise, it will be confused after when you recall that, will be confused. So this is my data set. Now I'm showing the mission that which are the inputs and which are the outputs. So whatever are the data I have, I'll store it in X. Whatever may be the target I have at the last. So if you see the data set, that will be the last column is target. So that is my anyway output. So I'm going to load that output in Y. Now I'm going to split my data set. So here I can use my test size as 0.4. So 0.4 means 40% data I am keeping for testing and 60% data I am keeping for training. And random state here, if you see, I'm taking 0. So every time the results will be updated. Results will be changed. So the randomness will be for each and every step, every iteration. Now here neighbors. Neighbors here I'm taking only 3. So this number you can take anything depending on your application, since it is very simple program. So I'm just starting with a low number 3. So 3 surrounding nearby I'm taking neighbors 3. Now I'm fitting my X train and Y train inputs, whatever I have trained, the inputs and outputs I am fitting using KNN. So KNN dot fit. If it is a logistic regression, previously we have done logistic regression dot fit. Log fit we have done. So like that, whatever algorithm you are going to take, that using that fit and your input and output training period of input and output you have to give. Then I'm going to predict last one. I'll give the accuracy. So here my accuracy is 93%. Means my algorithm predicted 93% exactly with the actual values, whatever I have in my test data set, and it is predicted almost 93% same. So here, if you change the random state here, the results you can see will be something somewhat updated. Here I'm giving the random state as somewhat 25. I'll again run it. Let's say accuracy will be changed or not. 96. The accuracy is changed. So depending on that test size and the random state, the accuracy or the level of training and level of predicting will be changed. A little bit change will be there. That you'll get while you practice so many algorithms on this, then you'll able to select what should value you have to take for a random state and what is the test side should be there for a particular algorithm for a particular project. That will be decided once you practice each and every day. So this is what a basic simple algorithm of KN. So next thing we'll go for one more algorithm. Hope you understand this. If anybody are getting struck, please give me in my comment box. So I'll wait for one more minute. Whether you are able to understand, you are following me or you are stuck in anywhere, am I going fast? Please comment it in the comment box. So I'll make it a little bit slow or I'll make it a little bit fast. Comment it. If everything is okay, I'll go for the next algorithm. The next algorithm, that is naive Bayes. So naive Bayes algorithm is also a type of classification algorithm. So as in a second day yesterday, I told you the types of machine learning algorithms. So how many types we have? You remember? One is the concept learning. Depending on that concept, concept learning means some assumptions will make, like if weather is very high, the if the temperature is very high, if the humidity is very low. So depending on these assumptions, will decide one hypothesis. Means one belief will decide, and depending on that belief, the machine will take the action. So that type of learning is called a concept learning. So there we will build a hypothesis, like a belief we will build there. So a concept, depending on that concept, will build a hypothesis. That is concept learning. Second one is instant based learning. So instant based learning means at a particular instant, depending on that features and depending on that situation, the machine has to take the action. So that is instant based learning. Third one is naive based, I mean probability based. So if event A happens, what is the probability of happening of B? If some event occurs at A, what is the probability of occurring B? So that's a probability. If something happens to if a cricketer is if a batsman is going to have a score of some 99 in continuous three matches, what is the probability of that particular cricketer of getting next match as a batsman or bowler? So what is the probability? Like probabilities, when you wherever you want to talk the probabilities, this is the best algorithm to use, naive Bayes. Naive Bayes algorithm works on completely on bias, biasing technique. Bias is nothing but, so naive Bayes classifier is one of the simple and most effective classification algorithm which helps in building the fast machine learning models that will make a quick prediction. So, of course, probabilities normally it will give the quick predictions. So, some examples of naive Bayes are our spam mails filtration and sentimental analysis in our social networks like Facebook or Twitter, and of course classifying articles, whether the article is a harmful article, like mostly naive Bayes algorithm we use to decide the Twitter comments. In Twitter comments, whether that comment is a harsh comment, whether it is a good comment. If you observe in Twitter, you'll get the marks, blue mark, red smiley. If it is a harsh, if it is a bad word, like that, to filtrate that, we'll use this algorithm in our social networks. So naive Bayes algorithm is comprised of two words. One is naive and then one is bias. Naive means it assumes that the occurrence of certain feature is independent of occurrence of other features. So for example, if you throw a coin, what is the probability of getting head or tail? So throwing a coin is completely, otherwise I will take one more example, like the weather prediction I'll take. So if I have two or three features, so each feature is completely independent of each other. Those three will not be, any dependency between them. So if A happens, there is no chance of B happening. Maybe there is a chance of B happening. That is not completely independent. But if these three elements are some dependency on the variable, I mean output. So for example, if the output is an apple, so here I'm taking features as shape, size, and color. So both three things are completely different. Color is not any dependency on the shape. Shape is not any dependency on the size. But if these three happens, there is some effect and it should be an apple or not. So output will have dependency on these three features, but the three features are independent to each other. That is called actually naive. So naive means occurrence of certain feature is independent of occurrence of other features. such as if fruit is so the same example just now I told you. So now bias. Bias is nothing but the it's named after some the scientist bias. So this is the formula we use in naive-Bayes classifier. So occurrence of A, event A, the occurrence of chance of happening A on the occurrence of B will be given by the occurrence of B by A and the probability of occurrence of A by a probability of occurrence of B. So naive-Bayes classifier works on this bias law. This is called a bias law. This already we have studied in some 9th or 10th marks, 10th class of maths while studying probability. This is the basic probability law, bias law. So naive-Bayes works on this formula. So here for the formula, A by B is called probability of hypothesis of A on the observed event of B, and probability of likelihood probability, previous probability, and marginal probability. So these are the elements we have to remember for naive-Bayes classification. So the main advantage of naive-Bayes classifier is it is very easy. Probability only one formula will use. And this is useful for binary and also multi-class classification. So binary, I already explained you, binary classification is in the outputs if we have only two variables. If you want to classify only two, yes or no, male or female, that is a binary classification. If you want to classify more than two in the outputs, then you will go for a multi-classification. So neighbors actually mostly will use a multi-classification. And it performs well for the multi-class predictions as compared to other algorithms. So this is the best algorithm for multi-classification algorithms. And mostly it is used for test classification. As I said, for the Twitter commenting filtration, we go for name base. Actually, in present smartphones or whatever, for that purpose, we'll use name base. So main disadvantage of naive Bayes is all features, it will assume that whatever I said, all the features are completely independent to each other. But in real time, few features are maybe dependent to each other, but naive Bayes, Newton's and naive Bayes, it completely assumes that these features are completely independent to each other. That is the main disadvantage of naive Bayes algorithm. So applications of naive Bayes are credit scoring, medical data classification, and real-time predictions. In real-time predictions we use and mainly spam filtering, sentimental analysis. So there are maximum three types of naive-Bayes models are there. One is Gaussian model. So Gaussian model normally observes that whatever distribution we have for the data. So when you plot the data, the distribution is completely, it assumes that whatever may be the data, it assumes that it is a normal distribution. Normal distribution, and it works, it builds depending on that normal distribution, it builds the model. And multi-nominal distribution, it is used when the data is completely, it's not normal, it is biased somewhere. It is screwed somewhere, positive screw or negative screw, it is biased somewhere. In that cases, we'll go for multi-nominal naive-Bayes algorithm. And Bernoulli, it is just like assumption. It's if the variables are completely independent, Boolean variables are there, and we are not able to do that problems using only in the dependency of the probability. So if we are not able to take the relationship between the features, yeah, as I said, completely if you assume that features are completely independent to each other, but in real time cases there may be a dependency. In that particular cases, we'll go for Bernoulli's models. So these are the main three models we'll see in naive-Bayes algorithms. So mostly, but in real time, mostly we use this Gaussian. That is the most efficient model in naive-Bayes. So we'll go for the practical session now. When naive-Bayes here, you just open a new workbook. A new workbook you can open and do your give the title for naive-Bayes and start importing the library. Start importing the library. So this is one type of loading your file. So instead of loading here, instead of session loading, uh, section one second here, so many collab sessions are open. It is not able to take that many sessions at a time, so I have to close all these sessions now. So instead of uploading the session upload, I can use here import.io. This is also same thing. It will be uploaded. The file will be uploaded in a drive only. But instead of doing this, we can do this also. That's why I kept here. This is one more, another type of loading the data. So if you type this import IO from Google Colab import files, so if you run this, here it will ask choose the file. Here we have to upload the file. Instead of uploading here, we just upload file here. Choose the file. So my file is document here, and I have created that file with some text, a negative line and a negative sentence and positive sentence. I have given a positive and negative for the output. So here it is uploaded. Document.csv is uploaded here. So this link will be shared to you. Naive based algorithm and also dataset is document.csv. So both I think already shared to you. So please check it. So here my data set is loaded here, uploaded here. So this thing actually, this thing we have studied up to now. This is our first step, loading the library. Anyway, I have created that this I just want to show this code to you. So I'll get it here first. So now uploading the libraries. So here I'm uploading test transcript and count vectorizer. So this count vectorizer works for the text. If you are any idea of NLP, you can know this function count vectorizer. Actually, vectorizer, what it will do, it will separate each and every word, and also in that particular word, it will separate each and every letter, and it will give some number to each and every letter. And whenever that word is repeating, that depends on the type, whichever type we are taking, whether we are counting as words or we are counting as letters or we are counting as sentences. So whenever it is repeating, the count will be repeated. If it is repeated two times, the count will be two. So it will create a matrix. The count will be created as a matrix. That works will be done by count vectorizers. So here we are using this complete program for our text. So text, if you see the data set, document.csv data set, if you open that, there you can see the complete text. Today I want to eat an apple. That is a positive sentence. Like that, you will see the text. So for that text, machines will not understand the characteristic, strings. So everything I have to give it to numerical values. So I have using count vectorizer. And then from SKLearn library. Now I'm here. I'm downloading multinomial and NB. So three models are there: Gaussian, multinomial, and Bernoulli. So here I'm using multinomial. Here you can use anything. Gaussian also you can use. Multinomial, NB means naive base. Multinomial, NB, naive base. So metrics means I just want to calculate the here accuracy. I want to calculate recall. I want to calculate how many times that word is repeated. That is recall how much accuracy level it is correctly predicting. That I have to calculate, and I want to see how many negative and positive values are there, how much level, extent level it is giving. So that precision I want. So all these things will come in metrics. So I'm importing the metrics. So all these things from sklearn library. So from this library, I am importing all these things: count vectorizer, matrix, multinomial NV, and train text split. So this is important. So again, pandas completely in frames I am going to use. So I said account vectorizer. count that words, how many times are repeated, and it will be kept in a matrix in frames. So I have downloaded the pandas, and now this is my variable message. So in that I have downloaded this document. So here I am giving names as messages and labels. So message is my feature, label is my output, and just printing how many instances are in my data set. There are 18, whatever 18 lines I have considered, 18 sentences I have given with the input and output. Now I'm separating that. So I'm telling that machine that X consists of all the inputs and Y consists of all the features, I mean labels. So I'm just uh, dividing that X and Y. I hope you understand all these things now. So I am not explaining again and again all these things. Now SK model. Now our next step is to train test split. So in that train test split, now here I am not giving any test size here. Test size I am not giving. Just I am giving X and Y. So this count vectorizer, this is the main thing in naive Bayes algorithm. So here fitting after giving training and testing, after splitting the data, here the fitting function will be done by the count vectorized. So it will create the matrix of words, how many times it is repeated. So with that, it will fit that exit train and Y train. Print that. So this is the words, whichever I have given in my instance, the 18 sentences, these words are, this is the first line words and how many times it is repeated, it is created as a matrix. CLF.fit is my multi-nominal model, particular multi-nominal NB I am using for fitting the line for this array. So now I have used, this is the function for naive Bayes algorithm, CLF dot fit, classification algorithm of naive Bayes dot fit. So using this fit function, I am fitting my exit line inputs and outputs. Now I will predict that how many positives and how many negatives are there. So these are the positive sentences I have created, and these are the negative sentences I have created using the test. And this is the accuracy matrix I got. So accuracy is 0.4% and recall is 0.25, precision is 1, and confusion matrix that will be discussed in optimization next class. I'll tell you what is the confusion matrix and how we will get this matrix. So confusion matrix normally we use to decide uh, our accuracy of machine learning completely not depend on only positive values. Suppose if it is predicting only 98% of positive values correctly, but if it is predicting only 40% of negative values correctly, then I cannot say my machine is working properly. I hope you understand what I am telling. Suppose I have in my data set, suppose I have some 70 rows of positive values, yes, and some 30 rows of negative values, no. Now my machine predicted almost 50%, almost 50 rows of positive values correctly. But in that 30 negative rows, 30 rows of negative values, it is predicting only 10 rows correctly. So not even half. In that cases, I cannot say my accuracy is more. Accuracy automatically it will come. More accuracy it will show because it is predicting almost 70%. More 60% of 70% of data of positive values correctly. But I cannot say my accuracy is more in that particular cases. So to predict a correct accuracy of a mission or a model, you have to go for a confusion matrix. So confusion matrix always gives you how many positive values it is predicted correctly, how many negative values it is predicted correctly, how many false negative, false positive will call. So true negative and true positive, true false negative and false positive. So that is the matrix it shows. That we will discuss anyway clearly in the next class, confusion matrix. So this is the basic, important thing for a classification algorithm to decide whether the classification model is correct or not. This is the base for a classification algorithm. So this is my accuracy levels, metric levels for my model, my base algorithm. So next, we'll go for one more algorithm. In logistic regression, I already told you here. Instead of using a normal straight line, we are going to use a sigmoid curve. So this is the formula behind that sigmoid curve. Instead of using y equal to mx plus c, that y equal to mx plus c, I will use in place of this z. So directly taking y equal to mx plus c, if the curve is like a straight line, all the points are gathering at a particular point itself. So when you give a slope at a point of time, that slope you will get zero. So you won't get anything at that particular point, or you will get completely consistent values at a particular time. So to avoid that, instead of giving y equal to mx plus 3, I'm just considering some exponential form so that here you won't get zero here, and this will not get a infinite value. So for that purpose only we are using this formula. So instead of directly taking y equal to mx plus c, I'm just taking e power minus y equal to mx plus c. So this is what logistic regression is there. And the next thing is unsupervised learning clustering algorithm. So unsupervised learning, in last class I already explained you what is the difference between supervised and unsupervised algorithms. So unsupervised algorithm means there won't be any labels. So unlabeled data we use. Unlabeled data we use. So unsupervised in supervised learning, whatever we give the data, up to now you have seen, we are giving the labels. Either it is a positive value, it is a negative value, it's a male, it's a female. So everything we are giving some labels. But in unsupervised learning, there won't be any labels. We'll just give some conditions or some similarities in the features. So depending on that similarities and conditions, the machine can able to divide that into some clusters. So cluster is nothing but a group. So whether it will be a defective group or non-defective. So in that defective group, any label will be there. Maybe it is a toy, it is a ball, it is a bat, any product will be there. But we don't know that particular label of that product. Just will have some condition. If that product is in a good shape, in a working condition, then it will go to a defective group. That's it. A group only we know. We don't know the product label, and also in the group also we don't know the product label. The name we don't know. So that cases we go for unsupervised learning. So in unsupervised learning, the subgroup is clustering. So in supervised learning, the subgroups are classification and regression. In unsupervised learning, the subgroup is clustering. So in clustering, the basic algorithm is k-means algorithm. So in k-means algorithm, what happens? So each and every point, it will create the distances for each and every point. It will see how much similarity is there. What is the similarity between two different points? So when you that similarity is calculated, then depending on that similarities, it starts dividing the points into 8 different clusters. So when that cluster has complete similarities, that will be grouped as a one cluster. So when some different points are there in that cluster which is not similar to the other points, then that will be clustered as a different group. Like that, we will group it, and we will cluster each and everything. So how that in that way that k-means will work. So for that k-means, here I am going to consider the data set of mall customers. So in mall first I'll download the mall customers data here. So we will share you this link also. This program we will share you k-means link. We will share you, and also mall customer we will share you. Mall customers first I'll upload this. I'll upload this. And you see this data set here. My customers data. Here this is
Madam, mall customer.
mall customers data, and also that link. We will share you in
Actually,
k-means. So k-means link we are going to share you now. So here in your data set, if you see the data set, so this data set completely consists of a gender, age, annual income, spending score. So this spending score is our output. How much spending score they have, depending on the features of their gender, their age, their income. These are our features. So now first step is importing the libraries. This is our first step. And next one is as it is the same step, loading the data. So here I have loaded the data, and I just want to see the first five rows whether it is downloaded clearly or not. So that's why I have given dot head. And I want to know about some information about the data. So I have given data.info. So here I have four columns, five columns I have. Customer ID is an integer value, and gender is a characteristic value, and age, annual income. So four integer values are there, and in 200 entities are there, entries are there. In that 200 entries, no null value is there. So actually info we use particularly for this purpose only. Just here we can see. If here null value is present, what we have to do? We have to use dot is null dot sum. So wherever that value is there, that value will be appeared in that particular cell. Then we can drop that null cell. Drop NA. We can drop that null cell if that is not affecting our variable. Now here in for the input, I am considering only 3 and 4 columns only. Only I am considering 3 and 4. What is my 3 and 4? I don't want gender. For my analysis, I don't want my gender. Only I want income. Income is enough for the credit score. So only I am taking columns of 3 and 4 in my data set. That's why ilog function I am using. Here column means all rows I want, but only 3 and 4 columns only I want for my X, my input. Run it here. So this is my two columns. And then so this is my salary income, this is my credit score. So for using these two, I have to cluster. I have to group in depending on the similarities. Suppose few people are in a similar way of 137 of their annual income and 83 is the credit score. So few people are so there. That people comes in this particular group. So I want to group it. I want to group. So for that, I am downloading that k-means clustering from a cluster module from sklearn library. the cluster module. I am from the SQL library. I am downloading this function. Tables. WCSS is nothing but the first basic clusters. How many clusters we want to decide, and how many clusters should be needed for a data set. So initially, I'm setting this WCC list, a cluster list. I'm initializing with 0. So empty set is there. Now I am giving if it will be, it's like an if loop. So whenever there is a similarity up to a random state 40, when there is a similarity, it has to add to this WCSS cluster. And now we'll fit that. Once you add that, we'll fit with that cluster, and then we will scale it again because that is completely, these two things are completely different values. We cannot plot these two values. So I am scaling here. Actually, the scaling process should be here. Before fitting the thing, I have to scale it. By mistake, I have done here, but no problem. Here, see, if you see, now these two values are in complete a particular range. I can do it now. So now I have did that line, initializing the clusters. Just this is the mat plot. Now I'm visualizing the plot. I have fitted already, and now I'm visualizing the plottings. By chance, I have somewhere I have left that running that this. It's already 8:30, so we will continue this same program tomorrow. Same session will start. So tomorrow we'll see clustering, and of course reinforcement learning. Tomorrow we'll complete, and we'll see some optimizing techniques also. So thank you. Keep going, and have a nice day. Thank you.